Hi guys, welcome to your second online lesson. I'm pretty sure this is going to be a review lesson because I vaguely remember that at the beginning of the school year we covered perimeter and area very briefly. I was thinking to try to recap what didn't get covered last year, but it all kind of hinges on itself. So I'm pretty sure we went over both perimeter and area at the beginning of the year. You may have already completed the practice pages. So the good news is once you complete this lesson, you may not have any practice pages to do. However, I would still like you to look for them on the off chance that we didn't actually do them, and I'm misremembering that. So pray that my memory is not totally failing me yet. Okay, so today we're going to be talking about perimeter and area. Some of this hopefully will be familiar. Not some of it. It hopefully will be familiar because I'm pretty sure we've covered it before. But I did want to go over it again because it's been a while, and I think at the beginning of the year there was a little bit more confusion, whereas it might make a little bit more sense now. So the first thing that we're going to talk about is kind of just the difference between the two. So with perimeter is the distance that goes around the outside of a shape. You measure the perimeter by adding up all of the sides. So for example, in this first shape, you can see that I have a rectangle. I've marked it as, I'm trying to move my computer a little bit closer. There we go. I've marked it as the long side is 4 inches and the short side is 2 inches. Now, remember with perimeter, we're adding up all the sides. So even though I only have 2 that are marked, 2 inches and 4 inches, I have 4 sides of a rectangle. Now, the other 2 sides are not, the lengths aren't given, but I can figure that out based on what I know about rectangles. So I know that rectangles have 4 sides and that there are 2 pairs of equal sides. So meaning that this side is going to be the same length as this side, and this side is going to be the same length as this side. So if I were to write it in with the pen that of course I had with me, I would actually know that this would be 2 inches as well, corresponding with the 2 inches that I have over here, and that this would actually be 4 inches as well, corresponding to the 4 inches that I have up here. So now I can find the perimeter because I have 2 inches, 4 inches, 2 inches, and 4 inches, and if I added those up, 4 plus 2 plus 4 plus 2, I would get 12. If I'm dealing with a square, we can kind of do the same thing, only on my square, I only have one side that has been measured. But I know that squares have 4 equal sides, meaning that this side, this side, this side, and this side are all the same length. So even though it's only written as 2 feet, I know that this side will also be 2 feet, and this side will be 2 feet, and this side will be 2 feet. And if I add them up, I have 2 plus 2 plus 2 plus 2, or 2 4 times, which would make it 8. So the perimeter would be 8 feet. The distance around would be 8 feet. How I like to think about perimeter is like if I have a yard and I want to put a fence around it, I have to measure the outside of my yard. I'm not going to measure the grass in my yard. I'm not going to measure this space. I just want to measure how much fencing it would take to go around it. Now, here, I have a really odd-shaped yard. This is not a shape that has a specific name. I just kind of drew something that had straight lines and it connected together. So it is a shape, but it's not something that we're typically used to seeing. But you can still find the perimeter of it because all of the sides are measured. So I have 2 meters, 5 meters, 7 meters, 6 meters, 5 meters, and 4 meters. And so I can still find the perimeter of it. I just add it up. So 2 plus 5 plus 7 plus 6 plus 5 plus 4, those are a lot of numbers. So when I see a lot of numbers like that, I try to go for the ones that I can easily make into numbers that are easy for me to add. And for me, the easiest numbers to add are usually things that add up to 10, because adding on to 10 is really easy. So I know that 6 and 4 is one way of making 10. And I know that 5 and 5 is another way of making 10. So right there, I have 2 10s, which I know is 20. My only remaining two numbers are 2 and 7. I know that 7 and 3 make another 10. So since I'm adding one less number to my 7, 7 plus 3 would make 10. So 7 plus 2 is going to be 1 less than 10, which would be 9. So I have 10 with the 2 5s, 10 with 6 and 4, and 9 with 7 and 2. 10, 10, and 9 make 29. So I would have 29 meters as the perimeter of this shape. Okay? I'm going to switch gears before we get into your book and talk a little bit about area now. So the main takeaway that I want you to get from perimeter is that you're measuring the distance around the outside of a shape, and you get the perimeter by adding up all the sides. You can use what you know about some shapes to find any numbers that they don't give you. For example, with our rectangle, we had 2 sides that were not labeled, but we know that in rectangles you have 2 pairs of equal sides. So even though these 2 sides weren't listed, we can see that these would both be 2 inches and these would both be 4 inches. Same thing with a square, only with a square, all 4 sides are equal. Now, if this one had any lengths that weren't given, it would make it really tricky to find the perimeter of it because we don't have the same rules that we can fall back on. But with the ones that we definitely know the rules for that shape, we can find the missing perimeter sides. So perimeter, space around, add it up. Okay. We're going to move on to area. I'm going to adjust my poster. This is my improvised whiteboard. All right, so area now is going, whereas perimeter was measuring the outside of a shape, area is going to be measuring the space inside the shape. So area measures the amount of space a shape takes up. And you can think about this. I think this is the example that they use in your book. If you think about a rug, you think about how much space that rug takes up on your floor, right? So it's not just the outside of the rug. The rug takes up a certain amount of space on the floor. So you can think of it as like if you were to put a rug over your shape, how much of your shape would take up or how much of the rug would take up the space of your shape. So you can find area a couple of different ways. The first way is if your shape is on a grid, you can count up the number of square units. So for example, my rectangle here, I have it laid out on a grid. I have squares that are all the same size, so I know that they all have the same value. So this square isn't bigger than this square. If they were different sizes, just like with fractions, we wouldn't be able to compare them. But because I've divided it into equal parts, I know that I can just count them up and find the number of square units. So I'm going to count 1, 2, 3, 4, 5. There's 6 in each row, and 1, 2, 3, 4 in each column. So that is also helpful for me because if there's part of it that isn't clear, I can kind of use what I know about rows and columns to figure out that it's going to be a grid all the way across. So if I continue counting them up, I'm going to go through by rows because it's a little easier for me to think of that way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there would be 24 total square units just from counting it up. Notice that my label, because labels are really important in measurement. Notice that my label says square units. So we don't know, when we don't know, we just say units because we don't know if it's going to be inches or feet or miles or centimeters or whatever. But we do know that there's a certain number of units and they're all the same size and they're all squares. So each square is taking up a little piece of this rectangle. So that's the first way. If your shape is on a grid, you can just count up the squares. It gets a little bit trickier. You can count up squares easily if your shape happens to be a shape that squares would naturally fall into. It gets a little bit more complicated if you have lines that divide some of the squares. But if it divides it neatly in half at a diagonal, then you can usually still figure out what the area is. But counting up square units is really the most useful with rectangles and squares because those square units fit really nicely in them. So that's one way to find area. The other way to find area is by using the formula length times width. And I've written it here in with a cursive L because that's typically how you will find it, length times width. So this is one of many formulas that you will probably be asked to memorize throughout your schooling career. And all you need to know is that A stands for area, L stands for length, and W stands for width. So when you have a square or rectangular shape, you can figure out the area by finding length times width. If you are finding the area of other shapes, the formula is going to change, but what we're just going to be focusing on is length times width. So in this rectangle, I have a length of 6 feet and a width of 4 feet. So I would multiply 6 times 4 to find the area. 6 times 4 I know is 24. Now, I still have square because we're still thinking of it in terms of squares, but instead of saying square units, I now know what the units are, so I'm going to say square feet. So 6 times 4 would be 24 square feet. We can also write it this way as the abbreviation for feet with a little 2. That 2 is called an exponent, and it means that you are taking that number, and it basically stands for squared. So feet squared, or square feet. Now, what's cool about this, and what's cool about the example that I used, is that on the top, you'll notice that I had 24 square units here and 24 square feet here. So if I were to take my rectangle, and if I were to draw out 6 equal lines for the 6 feet, if I were to break up my length into 6 portions, and then I were to take my 4 feet and break that into 4 equal portions, it would create the exact same grid that I have up here. So that's why we think of area as being in square feet rather than feet, because it's counting how many squares it takes up to fill that space. Okay, so that's kind of an overview of perimeter and area, and hopefully that's getting your brain kind of back into the groove of what area and perimeter, the difference between the two. So we're going to go ahead and launch into your lesson. I'm not going to spend a whole lot of time on this lesson since I do believe that you guys have covered it before. So go ahead and open up to page 272, which is the beginning of lesson 6. The first problem, and again, you may also find that when you open up your book, we may have answered some of these questions already. If that's the case, I would read through your answers again just to make sure that they make sense to you. But your work is going to be pretty light this week then because you've already done it. But we are doing some review because I think this was something that was confusing at the beginning of the year for a lot of you, and also it's just a good thing to touch back on. So Looking at the problem, it says Marissa has 64 feet of fencing. She is using the fencing to border a rectangular flower garden. Marissa wants the length of the garden to be 20 feet. If she uses all of the fencing, what will be the width of the rectangular garden? So you see kind of a picture there. It has the flower garden, and one side is 20 feet. So remember, a rectangle, it's going to have 20 feet on one side, and then the opposite side is also going to be 20 feet because you're creating the two length sides. So now it's asking us to figure out what the width sides are going to be if she's using all of the fencing. So we have 20 feet on one side, we have 20 feet on the opposite side. So 20 plus 20 together is going to be 40 feet. Marissa has 64 feet. So we would want to find the difference between 64 feet and 40 feet. We would want to take away the 40 feet, see what's left, and then divide it equally between both width sides to find the way around. So I know that 64 take away 40. If I were just dealing with 60 take away 40, I know that 6 take away 4 would leave me with 2. So 6 tens take away 4 tens would leave me with 2 tens. But I'm starting with 64. So 64 take away 40 would be the same thing. I'm going to be left with 20, but I'm also going to have that additional 4. So I have 24 feet of fencing left for both of the width sides of our rectangular flower garden. So now I need to think about how much would it be to equal 24 feet but have the same amount on both sides. So I'm going to think about what would it be if I split 24 exactly in half. So I'm going to think of what plus what equals 24. And I happen to know that fact because I've learned my doubles facts all the way up to 12, and I know that 12 times 2 is going to be 24. So our perimeter would look like 20 feet by 12 feet by 20 feet by 12 feet. So let's go ahead and look through the questions that they're asking. It says, A, to solve the problem, do you use perimeter or area? Explain how you know. So remember the difference between perimeter and area. Perimeter is measuring the outside, and area is measuring the space in between. So with our fence going around the yard, are we measuring around the outside, or are we measuring the amount of space in between? We're measuring the outside, so that's how we know that we are dealing with perimeter and not area. Question B says, how do you find the perimeter of a rectangle? Add all the sides. That's what I want you to write if you haven't already written it. Add all the sides. C says, how much fencing is there in all? We have 64 feet in all. What is the length of the garden? How many sides of this length does the garden have? What is the total length of these sides? Oh my gosh, so many questions. Let's break it down one at a time. What is the length of the garden? We know that there is a long side that says 20 feet because that's what the problem told us. So if we went back and we circled the numbers, underlined the question, and boxed in keywords, we would see that the two numbers that we have up there are 64 and 20. So 20 feet would be the length of the side of the garden bed. So next part of that question on D says, how many sides of this length does the garden have? Well, because we're dealing with a rectangle, we have 20 feet on the top length, and so then we have 20 feet on the corresponding bottom length. So we have two lengths that both equal 20 feet. And then it says, what is the total length of these sides? So your answers would be, what is the length of the garden? 20 feet. How many sides of this length does the garden have? 2. It has 2 sides. And what is the total length of these sides? You would have 20 feet plus another 20 feet for a total of 40 feet. So your answer, you might want to separate, since there's 3 questions in that one, for that one line, you might want to separate it by commas. 20 feet, comma, 2 sides, comma, 40 feet. All right, E says, how much fencing is left to make the other two sides? Explain how to find this length. So again, we took our total amount of fencing, 64 feet. We took away the 40 feet that we knew would be required for the 20 feet on both lengths. And then we found what was left over. So we had 64 take away 40 would equal 24 feet left over for both of the width sides. So you could just write it as the equation, 64 take away 40 equals 24. F says, explain how you can find the length of the other two sides of the rectangle. So remember, we have 24 feet left over of fencing, but we have two sides that we need to cover with it. So we would think, and we don't want them to be unequal because we're dealing with a rectangular plot here. So we want to have a certain amount on one side and a certain amount on the other, and both of them together would equal 24. So I'm going to think of 24, dividing it into two pieces, what plus what equals 24. And again, as we work through that process, we know that 12 plus 12 equals 24. So each side is going to be 12 feet. All right, on the next page, on page 273, it steps you through. It says rectangles have length and width. They show you, just like we showed up here, that we have two lengths and two widths on the sides. If you're, and then they're going to show you as an algebraic equation how to find the perimeter. So if you go, so it says to find the perimeter of a rectangle, you can add up the sides in any order. So remember, just like with multiplication, that commutative property says we can do it any way we want, and we'll still get the same answer. When we're adding, we can also add in any order and still get the same answer. So they have it written out, perimeter equals length plus width plus width. You could do it as length plus width plus length plus width. You could do it as width plus length plus length. You could do it as width plus length plus width plus width. Any way you want, it's going to get the same thing. But they have it written out as perimeter equals length and width plus width. Since the opposite sides of a rectangle are the same length, you can rewrite the equation as perimeter equals 2 times length plus 2 times width. So remember, we're having 2 lengths, 2 widths. They're just rewriting it in a different way. Underneath, it says use P to stand for perimeter, L to stand for length, and W to stand for width. So your equation for the perimeter would be P equals 2 times L plus 2 times W. You have 2 L's, 2 W's. When you add them all together, you're going to get the perimeter. They've also written it as 2L plus 2W. When you have an algebraic equation, and I think we've talked about this before, if you have a number right next to a letter, that means that you're multiplying the value of that letter times that number. So 2L would be the same as 2 times L. 2W would be the same as 2 times W. All right, the equation above is called the perimeter formula, and here is how to solve the problem from the previous page using the formula. So you can go through and check your work by looking at the formula. I would strongly encourage you guys to do this. I'm not going to take the time to do that in this video, but you can certainly take care of that. All right, at the bottom it says reflect. The perimeter of a rectangular poster is 14 feet and the length is 4 feet. Describe how to use the perimeter formula to find the width. So we're going to use the same formula of P for perimeter equals 2L, 2 times the length, plus 2W, 2 times the width. And we're going to solve it as an algebraic equation. So if you know the perimeter, you know the perimeter equals 14 feet. So you would have 14 feet in place of P. So 14 feet and a length of 4 feet. 14 feet is equal to 2 times 4 feet. We know that 2 times 4 is 8. So we're going to do the same thing that we did on the other side. We have our perimeter is 14 feet. We know that the 2 lengths, 4 feet, and another 4 feet, 2 4 feet would equal 8 feet. So we're going to take away 8 feet from the 14 feet that we have total. I know that 8 plus 8 makes 16. I know that 14 is 2 less than 16. So I'm going to take 2 away from one of those 8s. I have 8 plus 6 equals 14. So if I took away the 8, I would have 6 left over. That would be, for my 2w would equal 6. So now I need to divide my 6 by 2 to find the value of the width. So 6 divided by 2, we know our doubles fast. 3 plus 3 makes 6, so 6 divided by 2 would equal 3. So we now know all of the measurements. We know that the total perimeter is 14 feet. We know that the length is 4 feet, and we know that the width is 3 feet. Because if we had 3 feet plus 3 feet plus 4 feet plus 4 feet, we would get a total of 14 feet. Okay. If you turn the next page, so we're now on page 264, it says Keegan is building a rectangular play area in his backyard for his dog. The length of the rectangle is 30 feet and the width is 24 feet. What amount of fence does Keegan need to buy to make the play area? They have a picture, they have a model of 24 feet by 30 feet. You know that since it's a rectangle, you're going to have that 24 feet twice, and you're going to have the 30 feet twice. So you can add up the lengths, 30 plus 30 plus 24 plus 24, or they've written it a different way, 30 plus 24 plus 30 plus 24, which is probably how I would think of it as well, because I know that I can add 30 plus 20 to make 50, and I would have 4 more. Then I would have another 30 plus 20 would make another 50 plus another 4. So I would have 50 and 50 and 4 and 4. 50 plus 50 I know makes 100. 4 plus 4 makes 8. So it would be a total perimeter of 108 feet. Below that, it also says model it. You can also use words to help you solve perimeter problems. They've written it out as an equation, but using words in place of letters, so that it's a little bit clearer if you're not as familiar with the algebraic process. So amount of fence would be the same as the perimeter, is equal to length plus width, and then they're plugging in the numbers that they know. They know that one length is 30 feet, so the other length is also 30 feet. One width is 24 feet, so the other width is also 24 feet. You add them all together. Okay. On the following page, number 2 says, what formula can you use to find the amount of fence Keegan needs and why? So the amount of fence is the same as the perimeter of the rectangle. So you can use the formula for perimeter, P equals 2 times L plus 2 times W, to find the perimeter or find the amount of, to find the distance around the play area for Keegan's dog. Number 3 says, use the formula to find the amount of fence Keegan needs. So again, you would write it out as P is the total perimeter. Then you have 2 times the length. So 2 times, we know the length is 30, or you could think of it as 30 plus 30 would make it 60. You have 2 times 24, or 2 times the width. 24 plus 24 would be 48. And so together you would have 60 plus 48, or 108 feet. Number 4, Keegan uses the formula P equals 2 times L plus W to find the amount of fence he needs. Does Keegan's formula work? Why or why not? Now, I think this was a major sticking point at the beginning of the year because we hadn't talked as much about the distributive property of multiplication. So remember, there are 3 main properties of multiplication. Commutative property says that we can multiply in any order and get the same answer. Associative property is number 2, which means that we can group numbers in any way that we like when we're multiplying and still get the same answer. And the distributive property means that we can also break them apart any way we like and get the same answer. So for example, if I were to multiply 2 times 15, I could break apart the 15 and think about it as 10 plus 5 because that's going to make it easier for me. I can then multiply 2 times 10 to get 20. 2 times 5 to get 10, 20 plus 5 would be 30, so 2 times 15 would be 30. So let's look at Keegan's formula. He's saying P equals 2 times L plus W. He's grouping the L and the W together, But if we were to break it apart using the distributive property, we would have 2 times the L plus 2 times the W, because we need that 2 to be multiplied by both parts because they're grouped together with the parentheses. So if you were to break his answer apart, you would have the equation P equals 2 times L plus 2 times W, which you'll see from the previous page is exactly the same as what we have. So Keegan's equation would indeed work. Number 5 says, which formula do you think is easiest? That's going to be your personal preference. It does say why, so I would like you to go ahead and say which one you prefer and why you think that it's easier. So because just saying because it's easier, that's kind of a given. So I would like you to try to explain a little bit about why you think it's easier to think of it one way versus the other. All right, number 6 says, explain when to use the formula for the perimeter of a rectangle. So that's kind of a silly question because you use the formula when you're finding the perimeter of a rectangle. So what I think they're trying to ask is, when do you need to find perimeter? And when you find perimeter is when you're going around the outside of a rectangle. So that's what I would put there, is you use the formula when you are measuring the outside of the rectangle. All right, for numbers 7 and 8, I'm going to have you guys come back and do those on your own if you haven't already done them. And we're going to go ahead and move on, turning the next page to solving area problems. So we're now on page 276. So now I want you guys to kind of switch your brains. We've been talking about perimeter, which goes around the outside. And now we're going to be talking about area, which is the space in between a shape. So Kevin is making a rectangular mural using colored tiles. So again, we're dealing with rectangles, but we're thinking about how many tiles is he going to fit in that space. He buys enough tiles to cover an area of 112 square feet. So we know the area is 112 total square feet. Now, Kevin wants to find the width of the mural so that it can, Kevin wants the width of the mural to be 8 feet. So we're going to need to find the length so that we know that it will have a total area of 112 square units. So they have down below a picture it. It says you can use a picture to help you solve the area model. So if you know that it's a rectangular space. So start with a rectangle. And then we're going to go ahead and label it. The total amount of area that this rectangle is taking up is 112 square feet. So you see that in the middle. It has the width is 8 feet. And so that means that the length is going to be an unknown number of feet. So we would have and then below it says, since you multiply the length and width of a rectangle to find the area, think 8 times some unknown number equals 112. We can then work backwards to find the unknown number. Beneath that it says model it. You can also use words to help you understand the problem. So area of the model is equal to length times width. You know the width, you need to find the length. It says the area of the mural is 112 square feet. It can be covered by 8 rows of units that are each 1 square foot. The number of square foot units in each row is going to be the length of the mural. So that's basically just telling you the same thing that we had here. We know how many columns we have. We don't know how many rows that we have yet. Okay. I'm sorry, the other way around. We know how many rows, but we don't know how many columns. Okay. Number 9 says, write an equation to represent the area of the mural. So if we use the same equation as on the other side, we would have 8 times some unknown number. I would write in L for length equals 112. 10 says, describe how you can find the length of the mural. So we could work backwards. We could think our total is 112. If we multiplied some number times 8 to get 112, it makes sense to think that if we divide 112 by 8, we would find the unknown number. So remembering that inverse of multiplication and division, you can use multiplication problems to solve division problems, and vice versa, you can also use division problems to find the answer to multiplication problems. So in this case, since we know the answer to the multiplication problem, we're going to work backwards by dividing it by the factor 8 to find the other missing factor. All right, number 11 says, if Kevin uses all the tiles, what is the length of the mural? Oh, wait. Yeah, what is the length of the mural? So we're going to think, what times 8 equals 112? So this is, again, where I'm going to break apart the problem and think about it in an easier way. So when I think about 8, there's only a few numbers that when I multiply them by 8, I get a 2 in the ones column. And the first one that I can think of is 8 times 4 equals 32. So I'm going to keep that in my head and say, okay, so that gives me a 2 in the ones place and a 3 in the tens place. Now I need to think about what times 8 is going to get me 110, but take away the 3 tens that I already have there. So I'm going to think, okay, 110 is like 11 tens, take away 3 tens. What's 11 take away 3? I'm not so good with 11, so I'm going to go ahead and use my counting on strategy. I know that 7 plus 3 equals 10, so I think 8 plus 3, 8, 9, 10, 11. Yep, 8 plus 3 is going to get me 11. So now I need to think about what times 8 is going to get me 80, because when I add the 30 other ones that I have, or 30 other tens that I have from 32 when I multiplied by 4, then I really only need 80 more to get up to the 110 that I would need. So 8 times what equals 80? Oh, well, that's a simple one. I know that 8 times 10 is going to be 80. So I would have 8 times 10 and 8 times 4. So 4 plus 10 would make it 14. So 8 times 14 would get me the 112 total square feet of the mural. All right, number 12 says, Kevin notices another, and I'm going to just pause for a second and say, that's how I approach problems in my head. That's from a lot of practice of manipulating numbers. And it took me until, I think I've told you guys this story before, but it took me until I got to college to really start feeling how fun numbers are. You can break them apart in different ways to make it easier for yourself. So that's just how my brain thinks of it. If you find that confusing, that may not be how your brain thinks of it. So it's totally okay. I'm doing it in my head, but it's totally okay to write it out on paper. That is more than okay. It's also okay to use a totally different strategy. I'm just sharing with you how my brain thinks of it. And it's taken a long time to get there. When I was your guys' age, I was not proficient with adding and subtracting numbers in my head. I used my fingers. I still use my fingers for some things. So it's okay. Use all of the tools in your tool belt when you're finding numbers. You can write it out. You can use your fingers. You can make equal groups, whatever works for you. I'm just sharing it as a way of thinking about it because some of you may think about it the same way. If it's confusing to you, do it your way. Okay? Okay. So moving on. Number 12 says, Kevin notices another package of tiles that makes them a mural with an area of 152 square feet. Write an equation that can help you find the length of this mural if it is also 8 feet wide. So he finds another package of tiles. It doesn't change the width, but it is changing our overall area, which means that it's also going to be changing the length, right? So we have the same width, but now we are multiplying by a different length to have a different area. So we would think of it as 8 times some unknown number is now going to equal 152. We're going to use the same process of 152 divided by 8 is going to get us our unknown number. So 13 says, find the length of the mural Kevin can make with the package of tiles that covers an area of 152 square feet. So I notice that there's still a 2 in the ones place, so I know that I'm going to have a 4 times the 8 still because that equals 32. So now I'm going to take 30 away from 150. That's like 15 take away 3. I'm going to be left then with 8. And so, wait, is that right? 152, take away 30. Yeah, no, just kidding. Yeah, that's not going to work. So I know from working it through in my head that even though 4 times 8 equals 32, I have too many there. So I'm going to try a different number times 8 that will also get me a 2 in the ones place. So if I go through my 8 facts, the only other one that I can think of is 9. 9 times 8 is 72. So now I'm going to try it with taking away the 70 from 15. That would get me 8. That actually does get me 8. And so then I'm going to say, okay, I have 8 times 10 again is going to be 80 plus the 9 to get me 72. That would get me a total of 152. And so my 10 times the 8 plus my 9 times the 8 together, I would have 19 feet would be the answer. Again, how I'm doing it in my head, that may not be the clearest method for you, so you may need to write it out on paper. The main takeaway from how my brain is thinking about it that I would like for you to think about is that whenever you are multiplying multi-digit numbers, you can break them apart. That is the biggest takeaway. So if you're multiplying multi-digit numbers, it's totally okay to line them up and do your columns on paper like we've done before. But it's also worth noting that you can break apart your larger numbers into the different components. So thinking about it in expanded form, I just broke apart 152 and thought about it as I have 100 plus 50 plus 2. When I took away 72 from there, then I had 80 left over because 70 plus 80 is 150. And so that's just how I'm breaking apart the numbers to make it easier for me. Again, that's my brain thinking about it. So if I'm talking and you're like, "Bull, Teacher Jess, I do not understand," that is totally okay. Use the tools that work for you. Do the system that works for you. And if that means lining it up in columns on your paper, that is just as effective a tool as the way that I'm doing it in my head. And sometimes it's worth doing that anyway, because as you notice, I just jumped in and said, okay, we're going to be multiplying by 4 again, and that was wrong. And so it's important, if you write it out on paper, you can see the steps that you're missing. You can't do that as easily when you're doing it in your head. So although it's a valuable tool to know how to do it in your head, it's not the only way to do it, and sometimes it's not the most effective way. Okay, so our answer to 13 is 19 feet. Number 14 says, suppose that you know the length and area of a rectangle, how could you find the width? So again, we would be using our area formula, which is length times width. So we would place A for our total area equals length times width, and we could work backwards then by saying the area divided by the length would then equal the width. Same as if we had area divided by the width equals the length, which is what we did on the previous page. Okay, the bottom two problems, numbers 15 and 16, I'm going to leave for you to solve on your own. I do have your practice pages. Again, I'm pretty sure that we've already done these. So you may not have them as loose pages. You may not have them in your book. And guess what? Hooray! That means that you have a little bit of extra time this week. But again, I hope that you will at least listen in and work through the problems in your book just to kind of give yourself that refresher on perimeter and area. If you have not done the practice pages, please look for these pages. Look for pages 283 and 284 and 285 and 286. So again, remember those are double-sided pages. So one page 283 to 284, the other page 285 to 286. All right, that takes care of our lesson for this week. If you guys have any questions, please check in at the Google Hangout. Even if you don't have questions, please check in. It'll be great to see you and say hi. But if you need any help working on problems from either this week or last week, I'm there from 10 o'clock to 11 o'clock, Tuesday, Wednesday, Thursday, for any of your questions. And just to clarify, those times are open to anybody. So even if you watch the lesson, you don't necessarily have to just come on the day that you have your lesson. You can come anytime during those office hours. Okay, have a great rest of your day, and I'll see you guys next time. Bye.